Okay, here's question 5 from today's test. Slowly working my way through the 6 questions. So this is an easier one than most of the others. This is a factor theorem question, really. The polynomial f of x is defined as follows, and a is a constant, and we're told that x plus 2 is a factor of x. So 2 things to do. First, we have to find the value of a, and then we have to show that when a has got this value, f of x has just got one real root. So the first thing that we can say is that since x plus 2 is a factor, by the factor theorem, f of negative 2 must equal 0. So substituting in, this is what we get. Negative 2 cubed plus a times negative 2 squared minus a times negative 2 plus 14 equals 0. Negative 8 plus 4a plus 2a plus 14 equals 0. What do we get? 6a equals negative 6, and so we get very easily a equals negative 1. And look at that, that's a nice easy integer value to work with. Now we've got to show that when a has got this value, the equation has just got one real root. So I'll do that on the next slide. Okay, so sorry about the background noise. So what have we got? X cubed minus x squared plus x plus 14 is equal to f of x. So when that equals 0, what do we have? Well, by the fundamental theorem of algebra, f of x equals 0 will have 3 roots because the highest power is 3. So what we can do now is to factorise, and we're going to have x cubed minus x squared plus x plus 14, not 4, is equal to x plus 2. Now, it must be times a quadratic, so let's do some matching up. We want to get an x cubed, so we're going to have x squared here. We need to have a plus 14, so we must have plus 7 here. So what's going to go in this middle term here? Well, we've got negative x squared. It's going to come from 2 places. It's going to come from 2x squared minus 3x squared. So to generate the minus 3x squared, we must have minus 3x in here. So what we need to do now is to look at what the roots are of the quadratic. So roots of x squared minus 3x plus 7 equals 0. So the discriminant, which is b squared minus 4ac, is the thing we need to look at. And the discriminant here is 9 minus 4 times 1 times 7, which is negative 19, which is negative, so it has no real roots. So x equals negative 2 is the only, run out of room, the only real root. And I can't squeeze it in. There we are, the only real root. Excuse that horrible messiness at the end there. If we were asked to go further and find the 2 complex roots, though, you know that you could solve this equation here, and you would get 2 roots. They'd both be complex, and one would be the conjugate of the other by the conjugate root theorem. Okay, that's all for now. Thanks for watching, and I'll put some more answers up tomorrow.